All right, 16.8 is about a type of group called acetal or hemiacetal. All right, and I'll talk about what an acetal is, and a hemiacetal is half of what an acetal is, hence the hemi. All right, so if you take a carbonyl compound, specifically an aldehyde or ketone, and you add water to it or even an alcohol, in this case we're adding an alcohol to the carbonyl compound in the presence of acid. This just means we have to add acid to it. If one of the alcohols, all right, bond with the carbon, you form what's called the hemiacetal. Notice I have two oxygens now. This OH group right here came from the original oxygen. So these electrons from here popped up and grabbed the hydrogen from an acid, okay, an H plus ion. And my RO group attached onto here, and the hydrogen kind of gets plucked away. All right, it's not important what happens to all the atoms. If you'd like to know, I'd be more than happy to show you what's called a mechanism and kind of show you where everything goes, but it's not something that you need to know for this class. Okay, so you kind of have an alcohol group and kind of this ether group both on the same carbon. Notice I have an alcohol and like an ether group both on the same carbon. So that's called the hemiacetal. If you add a second alcohol to it, it replaces the OH group and you kind of get this two ether looking group. You kind of get two ethers on the same carbon. And that is what's called an acetal. And these kind of compounds are very common, especially in sugars, which we will see in the remainder of the slides. Okay, let me grab a pen. Something happens to my pen. There we go. Okay, acetal. So the addition of one molecule alcohol gives you the hemiacetal, which is exactly what I said on the previous slide. And then the hemiacetal can react with the second molecule of alcohol to form the acetal. Okay, and again, the hemiacetal has an OH and kind of this ether group, okay, or an OR, however you want to look at it. And an acetal has two OR groups, okay? So here's just kind of showing you what happens. If you add 1 mole of alcohol for every mole of aldehyde, you get the hemiacetal. If you add twice the amount of alcohol, you will get the acetal. And this is just kind of showing you a real molecule. Okay. Um, Cyclical hemiacetals are very stable molecules. So what's a cyclical acetal or hemiacetal? That's a compound where you have a carbonyl on one side of the chain. So let's say we have an aldehyde here. All right, so here's one carbon, 2, 3, 4, 5. Oh, there we go. And an OH group right there. Okay, so let me see. 1, 2, 3, 4, 5, 6. There we go. So if I have this aldehyde, I got this aldehyde with an alcohol this N, what happens is this alcohol kind of curls up onto itself and bonds right there. And these electrons kind of all kick up. This hydrogen is transferred then over onto that oxygen, and you form this kind of molecule. Okay, and this is what's called a cyclical hemiacetal. These are what sugars are. Sugars are either a 6-membered ring or a 5-membered ring, hemiacetal or acetal. Okay, it just all depends if it's a monosaccharide or a disaccharide. Okay, meaning one sugar or two sugars hooked together. All right, which we'll see in the next few slides. Okay, so these structures are very stable. This is where you kind of see these acetals quite a bit, is in the cyclical form. Okay, so here's the exact molecule I just drew, the 5-hydroxypentanal. Remember, you name aldehydes. This is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and hydroxy group is for an OH group that's hanging off of a chain. It's not your major parent compound. Okay, and this kind of curls up onto itself as they're showing here, and it bonds into there. Okay, so here's an example of glucose. This is a glucose molecule. You've probably seen this structure a million times in other books, biology books, or maybe another chemistry book, or a microbiology book, or an anatomy and physiology book. But pretty much it's a 6-membered ring. Here's your 6-membered ring, and you have an oxygen in the ring plus an OH hanging off of it, just like what we have here. Oxygen in the ring. Okay, so you kind of have like an ether in the ring, and then the OH is coming off of the same carbon. Now, what makes a hemiacetal or an acetal is the same carbon has the two oxygens bonded to it. Okay. So if you add another equivalent of your alcohol or another mole of alcohol, you can then replace the OH with another equivalent of your OR group. So you now have an acetal. Okay, this is the hemiacetal. This is the acetal. Okay, so here'd be an example. Excuse me, I gotta. Okay, so this is an example of a sugar. In this case, it's lactose, which is the sugar that you find in milk. And you can kind of see it's composed of two sugars. Okay, and you can see an acetal right here. Okay, and you have a hemiacetal right there. So this is an acetal because you have a carbon with two oxygens attached to it. And both of these oxygens have carbons attached to it, or R groups. So that's the acetal. This is a hemiacetal because one of the oxygens has an R group and the other oxygen has an OH group. Okay. Acetals can also be converted back to the aldehyde, or hemiacetals. Okay. In the presence of water, this time an acid, you can actually break down your acetal or hemiacetal back to the aldehyde ketone. And that's kind of what our bodies do with sugars. When sugar goes into our stomach is hydrochloric acid. The hydrochloric acid then, and you have water in there. So as soon as your sugar, which is an acetal or hemiacetal, go into our stomach, you have water and acid. It breaks down into the aldehyde, and that's kind of what our bodies then process, is the aldehyde form of the sugar. Okay, so here they're just showing you a real example. You got an acetal, the water kind of breaks these bonds and puts the carbonyl in place of it. Okay, so that is pretty much it for chapter 6. Section 6.7, you might have noticed I did not talk about section 6.7. That's all about how our eyeball works and how our vision works. It's pretty interesting. If you're interested in reading about it, I have it on the slides. You're more than welcome to read about it. It's basically related to what we've been talking about in 6.6 and all the double bonds and things like that. So if you're interested, go ahead and read that. See you in class. If you have any questions, feel free to ask.